According to NESC Table 230.1, Rule 230.1, b. Open conductor spans are permitted over buildings, including metal roof buildings, provided that the building does not exceed 60 feet in height. The minimum vertical clearance between the conductors and the roof surface must be as follows, as per NESC Table 230.1, Rule 230.1. C for 12 kilovolts, 9 feet. Firstly, the conductors must be supported by structures that are securely anchored to the building. Secondly, the open conductor span must be marked with warning signs visible from both sides of the building. Thirdly, the conductors must be equipped with lightning arresters at both ends of the span. Fourthly, proper grounding and bonding should be provided to prevent electrical hazards. It is advisable to consult a qualified electrical engineer for a comprehensive design and installation plan that complies with all applicable codes and regulations, including NESC. Open conductor spans, particularly at 12 kilovolts, present significant safety considerations that must be meticulously addressed to ensure the protection of personnel and property. Understanding the relevant codes and standards, especially the National Electrical Safety Code, or NESC, is paramount. The NESC provides detailed guidelines for the installation and maintenance of electrical power and communication systems, including overhead lines. When dealing with open conductor spans over buildings, the NESC specifies requirements for clearance, grounding, and structural support, among other things. The permissibility of installing a 12 kilovolt open conductor span over a metal building is contingent upon meeting specific criteria outlined in the NESC. Table 230.1, Rule 230.1 of the NESC permits such installations, provided that the building's height does not exceed 60 feet. This height restriction is crucial because it directly impacts the required clearances and potential hazards associated with the high-voltage conductors. If the building exceeds 60 feet, alternative methods for routing the conductors should be explored, such as using underground conduits or insulated cables. Clearance is a critical factor in ensuring the safety of open conductor spans. The vertical clearance between the conductors and the roof surface must meet the minimum requirement specified in NESC Table 230.1, Rule 230.1. For 12 kilovolt conductors, a minimum clearance of 9 feet is mandated. This clearance is designed to prevent accidental contact with the conductors, especially by individuals working on the roof or using equipment that could come into proximity with the high voltage lines. It is essential to measure and verify this clearance during installation and periodically thereafter to ensure ongoing compliance. In addition to vertical clearance, horizontal clearance from building walls and other structures must also be considered to prevent arcing and potential fire hazards. The NESC provides specific guidelines for horizontal clearances based on voltage levels and environmental conditions. Supporting structures for the conductors must be robust and securely anchored to the building. These structures should be designed to withstand the weight of the conductors, as well as any additional loads imposed by wind, ice, or other environmental factors. The anchoring system must be capable of resisting pull-out forces and vibrations to ensure the long-term stability of the installation. Regular inspections of the supporting structures and anchors are necessary to identify any signs of deterioration or damage. Warning signs are essential for alerting individuals to the presence of high-voltage conductors. The open conductor span must be marked with warning signs visible from both sides of the building. These signs should clearly indicate the voltage level and potential hazards associated with the conductors. The signs should be made of durable materials that can withstand exposure to the elements, and they should be placed in prominent locations where they are easily visible. The use of international symbols for high voltage is recommended to ensure that the warnings are understood by individuals who may not speak the local language. Lightning arresters are critical components for protecting electrical equipment from voltage surges caused by lightning strikes. The conductors must be equipped with lightning arresters at both ends of the span to divert these surges to ground, preventing damage to transformers, switchgear, and other sensitive equipment. The lightning arresters should be selected based on the voltage level and surge current capacity required for the specific installation. Regular testing and maintenance of the lightning arresters are essential to ensure the proper functioning. Grounding and bonding are fundamental safety measures that help to prevent electrical shock hazards. Proper grounding and bonding should be provided to ensure a low impedance path for fault currents to flow back to the source, tripping circuit breakers or fuses and de-energizing the circuit. The grounding system should comply with the requirements of the National Electrical Code, or NEC, and the NESC. The metal building itself should be properly grounded to prevent it from becoming energized in the event of a fault. Bonding connections should be made between all metal components of the electrical system, including conduits, enclosures, and equipment frames, to ensure equipotentiality and minimize the risk of shock. Consulting a qualified electrical engineer is highly recommended for the design and installation of a 12 kilovolt open conductor span over a metal building. An experienced engineer can provide a comprehensive assessment of the site conditions, develop a detailed design plan that complies with all applicable codes and regulations, and oversee the installation process to ensure that it is performed safely and correctly. The engineer can also provide guidance on ongoing maintenance and inspection procedures to ensure the long-term reliability and safety of the installation. A comprehensive design and installation plan should address all aspects of the project, including conductor selection, clearance calculations, structural support design, grounding and bonding, lightning protection, and safety procedures. The plan should be reviewed and approved by the relevant authorities before any work is commenced. The installation should be performed by qualified and experienced electrical workers who are familiar with high-voltage safety practices. Regular inspections and maintenance are essential for ensuring the ongoing safety and reliability of the open conductor span. The inspection should be performed by qualified personnel who are trained to identify potential hazards and defects. The maintenance should include cleaning of insulators, tightening of connections, and replacement of damaged components. A detailed maintenance record should be kept to track the history of inspections and repairs. In summary, the installation of a 12 kV open conductor span over a metal building requires careful planning, adherence to applicable codes and regulations, and the involvement of qualified professionals. By addressing all of the safety considerations outlined above, it is possible to create a safe and reliable installation that will provide years of trouble-free service. The National Electrical Safety Code, or NESC, is a crucial standard that governs the installation and maintenance of electrical power and communication systems in the United States. It provides detailed guidelines for ensuring the safety of workers and the public from hazards associated with electricity. When it comes to overhead power lines, the NESC specifies minimum clearances from buildings, ground, and other objects, as well as requirements for conductor strength, grounding, and insulation. The NESC is updated regularly to reflect changes in technology and industry best practices. Compliance with the NESC is essential for ensuring the safety and reliability of electrical systems. Open conductor spans, while sometimes necessary, present inherent risks due to their exposed nature. These risks include the potential for accidental contact, electrical shock, and damage from weather events such as wind, ice, and lightning. To mitigate these risks, it is essential to adhere to the NESC guidelines and implement appropriate safety measures. One of the key considerations for open conductor spans is clearance. Clearance refers to the distance between the conductors and any surrounding objects, such as buildings, trees, or the ground. The NESC specifies minimum clearance requirements based on the voltage of the conductors and the type of object being cleared. These clearances are designed to prevent accidental contact and ensure that the conductors do not pose a hazard to people or property. In the case of a 12 kV open conductor span over a metal building, the NESC requires a minimum vertical clearance of 9 feet between the conductors and the roof surface. This clearance is intended to prevent anyone working on the roof from accidentally coming into contact with the energized conductors. It is important to note that this is a minimum requirement, and in some cases, a larger clearance may be necessary to ensure adequate safety. In addition to vertical clearance, the NESC also specifies minimum horizontal clearances from building walls and other structures. These clearances are designed to prevent arcing and potential fire hazards. The horizontal clearance requirements vary depending on the voltage of the conductors and the type of structure being cleared. Grounding is another critical aspect of open conductor span safety. Grounding provides a path for fault currents to flow back to the source, stripping circuit breakers or fuses and energizing the circuit. This helps to prevent electrical shock hazards and equipment damage. The NESC specifies requirements for grounding electrodes, grounding conductors, and bonding connections. The grounding system should be designed and installed in accordance with these requirements to ensure its effectiveness. Lightning protection is also an important consideration for open conductor spans. Lightning strikes can cause voltage surges that can damage electrical equipment and pose a safety hazard. To protect against lightning strikes, open conductor spans should be equipped with lightning arresters. Lightning arresters divert the surge current to ground, preventing it from damaging equipment or causing injury. Structural support is essential for maintaining the proper clearance and preventing the conductors from sagging or breaking. The supporting structures must be strong enough to withstand the weight of the conductors, as well as any additional loads imposed by wind, ice, or other environmental factors. The NESC specifies requirements for pull strength, conductor tension, and guying. The supporting structures should be inspected regularly to ensure that they are in good condition and able to withstand the expected loads. In addition to the technical requirements of the NESC, there are also several safety procedures that should be followed when working with open conductor spans. These procedures include wearing appropriate personal protective equipment such as rubber gloves and insulated tools, maintaining a safe distance from energized conductors, and using proper grounding techniques. Qualified electrical workers who have been trained in high voltage safety practices should perform all work on open conductor spans. It is also important to have a written safety plan in place that outlines the procedures for working safely with open conductor spans. This plan should be reviewed and updated regularly to ensure that it is current and effective. Finally, it is important to remember that electricity is dangerous and should be treated with respect. Open conductor spans pose a significant risk of electrical shock and should be approached with caution. By following the NESC guidelines and implementing appropriate safety measures, it is possible to minimize the risks associated with open conductor spans and ensure the safety of workers and the public. The use of appropriate hardware is crucial for ensuring the long-term reliability and safety of the open conductor span. The hardware should be selected based on the size and type of conductor, as well as the environmental conditions. The hardware should be made of corrosion-resistant materials and should be installed in accordance with the manufacturer's instructions. Regular inspections of the hardware should be performed to identify any signs of corrosion or damage. The conductors themselves should be inspected regularly for signs of wear or damage. Any damaged conductors should be replaced promptly to prevent them from breaking or sagging. The insulators that support the conductors should also be inspected regularly for cracks or other damage. Damaged insulators should be replaced promptly to prevent them from causing a short circuit. The area around the open conductor span should be kept clear of trees and other vegetation. Trees and vegetation can grow into the conductors, causing a short circuit or a fire. The area should be cleared regularly to prevent this from happening. The public should be educated about the dangers of open conductor spans. Warning signs should be posted in the area to alert people to the presence of the conductors. People should be instructed to stay away from the conductors and to report any damage or hazards to the utility company. The utility company should have a system in place for responding to reports of damage or hazards to open conductor spans. The system should include procedures for dispatching qualified personnel to the site to assess the situation and make repairs. The utility company should also have a system in place for tracking the condition of open conductor spans. The system should include records of inspections, repairs, and other maintenance activities. These records should be used to identify potential problems and to schedule preventative maintenance. Open conductor spans are a critical part of the electrical grid. They provide a reliable and efficient way to transmit electricity from generating stations to consumers. By following the NESC guidelines and implementing appropriate safety measures, it is possible to ensure the long-term reliability and safety of open conductor spans. This discussion provides a comprehensive overview of the safety considerations for installing a 12 kilovolt open conductor span over a metal building. It covers the key requirements of the NESC as well as other important safety measures. By following these guidelines, it is possible to minimize the risks associated with open conductor spans and ensure the safety of workers and the public.